So part 3 of this Lewis structure video is going to talk about formal charge, and we're also going to hit on the idea of resonance. So formal charge is, by definition, the charge that we assign to an atom in a molecule in very artificial situations, because we are assuming that all atoms have equal electronegativities. So no electrons are being pulled one way or another, so no polar bonds essentially. This is going to help us decide between possible Lewis structures. If you're not sure and there's a couple choices, it's what's going to help us. So to assign formal charges, we are going to follow these rules. All non-bonding electrons belong to the atom which they are around, which makes sense. So non-bonding pairs. And then for any bonds that you have, half the electrons belong to one atom, the other half of the electrons belong to the other atom. And then the formal charge is going to be the difference between how many electrons we've assigned to the atom versus how many electrons the atom's really supposed to have in its valence shell. Once we've assigned formal charges, in order to differentiate between the possible structures, we're going to follow these rules. The structure that you want to choose is the one that is going to keep formal charges low, and it's going to give the more electronegative atoms the negative formal charge as opposed to a positive formal charge. And again, remember, these formal charges are not real. They're made up for us to figure out Lewis structures a little more easily. So, if you have several structures to pick from, you're going to choose the Lewis structure which the atom's formal charge is closest to 0. And you're going to choose the Lewis structure. I feel like we just did this. You're going to choose the Lewis structure where the atom has the greatest electronegativity. So here is an example. You've got, on the left structure, you've got 1, 2, 3, 4, 5, 6, 7 electrons assigned to nitrogen when it's only supposed to have 5. So the formal charge is 2 higher than it should be, so it's -2. Carbon has 4 electrons. We assign 4 electrons to it because it has 4 bonds and no free electrons. So its formal charge is 0. And then oxygen is actually short one. 1, 2, 3, 4, 5 electrons are assigned to it, but it's really supposed to have 6. So oxygen gets a +1. That's not really good numbers. Oxygen is most electronegative. It should have the negative. And anytime you give something a formal charge of 2, that's kind of bad. So let's take a look at these two, which have much better numbers. But let's go through and prove where the formal charge is coming from. So 2, 4, 6 for nitrogen. So supposed to have 5, so -1. Carbon is okay for, excuse me, so it gets a 0 formal charge. Likewise, oxygen has 6, and it's supposed to have 6, so it gives a 0. Moving on to this second structure, 1, 2, 3, 4, 5 electrons for nitrogen, and that's what it's supposed to have, so 0. Still 0 for carbon. Now oxygen gets the negative because it's been assigned 1, 2, 3, 4, 5, 6, 7, so 1 extra than it should have. So we're going to cross this one out for sure. Now we got to pick between these two. They're all pretty low, but oxygen gets the more negative here, whereas nitrogen gets it here. So this is actually most likely the structure that you're going to see. All right, another example. You've got CO2. We know that it's going to be like this, but what's wrong with doing this structure? Let's let formal charges show you. So valence electrons, 6, 4, and 6. Here we've assigned oxygen 6, so that's good. Carbon 4, oxygen 6, so formal charges here are all 0. Here, formal charges 1, 2, 3, 4, 5 electrons for oxygen, so it's short one here. This oxygen has 1 extra because 2, 4, 6, and then 7. So this one's not looking so good. If we look at formal charges, that helps support that. This is a much better choice than this one because these are 0, whereas these are +1s and -1s. So the more likely choice for Lewis structure is the double bonded one because it has the lower formal charges. All right, last idea with this Lewis structure stuff is the idea of resonance. So Lewis structures for certain atoms don't match experimental information. So for example, the bond lengths in CHO2 minus predicted by the Lewis structure are really wrong. So if we do the Lewis structure for CHO2 minus, this is what we would come up with. But what measurements show is that what should happen is this double bond should be shorter than this single bond. Remember, the higher order bond you have, the shorter it is. But that's not really true. Both bonds have an equal length. So how do we justify the facts from data measurements with this Lewis structure that we have drawn? Well, as it turns out, you've got something called resonance going on. Resonance is where the structure is kind of a median, where electrons are kind of a little free-flowing. So here's the idea that we're looking at in terms of resonance. So you've got one atom having a single bond, one atom having a double bond. But what says that it's the top one that has to have the double bond? Why couldn't it be the bottom one? So resonance implies that, well, the structure really flip-flops between these two. So sometimes the double bond is up here, sometimes the double bond is down here. However, that doesn't satisfy all the information because it doesn't show different bond lengths, even if we're looking at a different molecule. What it shows is that you really have 1.5 bonds for each of those atoms. So that's the only way to get the length being the same, where it's the same kind of bond between both carbons and oxygens. So showing it kind of like a dashed line is more appropriate than flip-flopping these structures, because this makes it look like it's either this or this. This one lets you see that the structure is kind of free-floating in between. And okay, I was thinking I had another example, but obviously I don't. So resonance you get a chance to work with a little bit more. We can talk more about that in class as well. Your book has some nice examples, so make sure you take a look at that. All right, so that's the end of the Lewis structure PowerPoint.